Okay, factoring. So there are many types of factoring, and briefly, so these are the notes on what factoring is. Two things as far as vocabulary. We're going to look at the factored form, and you probably have seen FOIL before in Algebra 1. We're not going to really stress FOIL because you could have more than two binomials multiplied together at the very beginning of where we are in the factoring section. And so we are going to talk about distributive property. It's the same end product as what you called FOIL, but distributive property can be applied to more than just two binomials. So we're going to stress distributive property. And as we practice more, you will understand how that works out. And so first of all, we have these things where we're going to be writing a quadratic equation if I give you the roots. Remember, that's where our parabola crosses the x-axis. So if I give you two roots, so the parabola has crossed at 7 and 2. Basically, that means x equals 7 and x equals 2. So you've taken these numbers and that is what you got. So what I want to do first is I want to set that equal to 0. I want to have two equations. So I need to move those numbers over with my x. So how do I do that? In this case, both of these are positive, so I need to subtract to the other side. So what I have now are two short equations, and on the sides with my variables, I have two binomial expressions set equal to 0. And then I'm going to multiply those two binomials together right here, equal to 0. And so what happens is, to do that, I'm going to distribute to multiply them together. So this is where you might be accustomed to calling this FOIL, and I'm going to say distributive property. So distribute. So that would be x times x to be x squared, x times the 2 to have negative 2x, and then I am done with my x distributing. So I'm going to distribute negative 7 to get negative 7x, and I'm going to distribute negative 7 to the negative 2 to get positive 14, and then I just need to combine like terms to get my quadratic equation in standard form. So, and I'm going to take this concept and I'm going to use it to go backwards to factor. So the next problem, we're going to start with a quadratic equation and I'm going to break up this middle term into two terms, and I'm going to do distributive property in reverse to get these two binomials. So let's see what that looks like. So here I have a quadratic equation, and to be able to break this middle term up into two pieces, I first need to know what my a times c is. So remember my ABC. So 15 times 1 is a number 15, pretty simple in this problem, and I need to know factors of that number. I need those factors so that I get two factors that will add up to my b term. So I have all of these factors, 5 times 3, negative 5 times negative 3, because I need them to add up to a positive 15, which is what I got. So that adds up to an 8, which I have a negative 8 in the center. If I do negative 5 and negative 3, I get a negative 8. So I need to multiply this out. What number do I get? So what multiplies up to this 15 and at the same time adds up to this middle number? You should have done this in Algebra 1, so maybe this is ringing a bell, but maybe you didn't spend so much time on when this a is not a 1 here in the front. So here's my two magic numbers. They multiply up to that 15, they add up to the negative 8. So I rewrite. I've got my first term, the 15x squared, so I keep that. I keep my 1, and I do have my negative 8 here because it's negative 5 minus negative 3. That's negative 8. So it's hiding here in these two terms. Now what I'm going to do is I'm going to look at these two terms, and I'm going to factor out a GCF. I'm going to do distributive property in reverse. So I'm going to take these two, and I'm going to go, if I had a distributive property problem right here, what could I distribute out of both of these? So, so you're sort of thinking of multiplication, sort of thinking of division. What's in 15 and in 5? 5. And I also have x's in both of these. So 5x right here. And if I do that, 5 and what gives me 15? Oh, 3. And 5 and what gives me 5? 1. And then think about that. So if I did all of this right, and so I had an x here, I have an x here, so I won't have an x here. So if you think about this, 5 and 5, that's my 15. Okay. 5 and 1, that's my 5. Okay. Then an x and x, that's my x squared. X, no x here, that's my x. Okay. So distributing this, I get back to these two terms. So you're thinking kind of distributive property in reverse. And that's what factoring is all about. How about over here? You can kind of cheat your way into factoring right here, doing a GCF right in this spot, because this must match this one here. So this needs to be 3x minus 1. You already got 3x minus 1 here. So if this is 3x minus 1, what do I divide out of this negative 3x to get positive 3x? Oh, must be a negative 1. So does it work over here? If I get a negative 1 right here, and this was positive 1, do I need to divide out a negative 1? Yes, I do. Okay, so there's that. My final answers right here are two binomials multiplied together. The first one is these two binomials, which are exactly the same. Okay. The second binomial is, what are these greatest common factors right here in the front? 5x minus 1. That makes the second binomial. Okay, there you go. That's that factoring. We'll make more sense of it. We will practice more as you are in class. Maybe this slide should have come first because it's GCF. It would have made the other one make more sense. Probably. I need to know what divides into both 12 and in 18. Greatest number? 6. Okay, so I have a 6 here. What variables do I have in common in both of these? Well, I have an x squared. I have an x. What's the most x's I can take out here? Well, I couldn't take out 2. I don't have 2 x's here. I only have 1, so I can take out an x out of both of them. Do I have y's in here that I could divide out of both of these? Oh, yeah, I have 1 y. So 6xy is my greatest common factor of both of these terms. So I'm going to divide it out of both of them. All right, so I'll divide it out of both of them. What will I have left over? So it's kind of like I'm creating distributive property. So this times what will be left? 12 divided by 6, I have a 2 left. If I divide x out of x squared, I will have x remaining. And if I divide y out of y, I won't have any y terms left. I have subtraction in here. I didn't divide out any negatives, so I have positive. 18 divided by 6 will leave me with 3. I'm dividing xy out of xy. I won't have any variables left. I have created a factoring out GCF, and it's distributive property. You could check it. 6 times 2, I get a 12. X times x, I get x squared. And if I multiply y times this term that has no y, I will have a y on my term. And then 6 times your 3, you get your 18 back. And you have no variables here, so if you multiply this number, this constant, times this term, which has your variables, you get your xy back out. So you can check yourself. And finally, we have this thing called factoring by grouping. If you look at all 4 of these, this does not look like, back here, a trinomial. So you won't be doing this a times c. Let me break it up in the middle and do this factoring that we had done a while back. Maybe it's greatest common factor. So let me look at all 4 of these. Do I have a greatest common factor of all 4 of these terms? 7 and 6, nothing in common, but maybe 1. 7, 6, and 14. 7 and 14 have a greatest common factor, but you throw in that 6, and no, that doesn't work. 6 and 12 do, but if I do all 4, no, I don't have a greatest common factor of all of them. Let me look at these 2 at this time. Well, remember 7 and 6 only had 1 in common, but if I look at my variables, oh, I have x's in both of them. So let me take out an x. And then what I have left over is just, well, 7. I still have an x left. Remember, I couldn't take out 2 x's. There's only 1 x here. I couldn't take out any y's, so my y squared is still here. So this is what I have remaining right here. The only thing I could take out was x. Sometimes that's all you can take out as a variable. Let's look over at these other 2. That's why it's called grouping. We group these 2 together, then these 2 together. Let's see, 14 and 12. All you can divide out is 2. So how about variables? I don't have x's in both of them. I do have y's. I can't take anything out. I say take out as in dividing. Anything more than a single y, you have 3 y's, as in y times y times y, but all you have is a single y. So let's divide out 2y. This would leave you with 14 divided by 2, so you have 7. And the y's, you will have no more y's in your term. and you have x left. You did not divide out any x's, so x is left remaining there. 12 divided by your 2, you have 6. Y to the third, y times y, divided by y, you have y squared. So kind of like the end of the factoring we had done 2 slides ago. Do these two match? Oh, yeah, they do. So that would be my first binomial factor here. And what are your GCFs? What could you divide out of this pair, what's out here? That goes into your last binomial. So that is the 4 types of factoring that we are going to do. And you'll just have to see if you can match up any polynomial to see how you factor. And that's it.